Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be reviewing the DK2 motion system from the guys at Sigma Integral, a commercial made in the USA heavy motion solutions company located in California. A true turnkey bolt-on motion solution with 50 millimeters of travel, using some unique design elements to give the driver a very good motion experience. Time to put it through the SRG's review process and see how it does. So, let's get to it. So let's take a closer look at this DK2 system and the components that are in it. This is the controller box. Now the controller box came in its own section in our big box that we got with this. And it was a really nice packing job, by the way they do this custom foam molding for these things. The controller was on the top when I pulled that off in its own section of the foam. When I pulled that up, it revealed the cabling and the brackets, the hardware as far as fasteners go. So, and then underneath those, you peel another layer off, and the actuators are sitting down there on the bottom layer. All nicely done, very professional looking. Yeah, just top tier stuff. When you open the box, you say, wow, these guys have got it together. Now, this box is kind of a cream color, even though it might look more white on my video. I'm not sure. It's got some logos on the back. We'll talk about the back first on the what we got as far as the mains plug. And this is for 110, but it will also support up to 250 volts. So it's auto switching. So we can use this in Europe also with the right plug. And it is a fuse. You can see the picture of the fuse there on the cover. And of course we have our switch right there. We have some logo there. The company's name is Sigma Integral or Integrale. Over here you can see it says this is the DK controller and made in the USA. By the way, yeah, first sim racing oriented type system for motion that I've seen made in the USA. So it's good to see more manufacturers coming into the market, number one. Number two, one from the USA. Being from the USA is kind of nice. All right, so we've got a cooling fan over here, and this will run all the time. I actually turned the box on to see. On the bottom, we have some little rubber feet here. They're clear rubber, so it's hard to see them. We have one at each corner, and we'll go around to the front. We have some cooling vents here. You can always see a little power supply in there or something, but we'll get to that later when we get to our look inside. Here we have all the connections, and you can see we have on the bottom will be our data connectors, and on the top part that is going to be the power connectors. It has a cool little formula car here that tells you exactly which one should be positioned where based on the numbers. Very cool. They got that printed out for you. And we have an interface for our PC over here. And that's actually an RJ45. We'll talk more about that later. All right, so that's the controller box. Now we get a set of cables, as you might imagine, and we get one cable each. Let's see, this is the power cable, and these are all shielded cables. They made sure to tell me that because they knew I was going to be looking for it somewhere. But yeah, fully shielded cables here for the power, and it's a 4-pin Molex. You can see right there. Same thing on the other side. Nicely done cables, no shrink wrap, and you can see they have like that factory mold strain release stuff on the bottom there. Little locking tab. Then we have the data cables, and of course they have more pins in them. They have 8 pins. Same kind of cable relief over there. And these are also fully shielded. So all the cables are fully shielded. It's just one of the things that they wanted to make sure they did. They told me when they did the manufacturing of this kit. We have a power cable, and of course that's kind of self-evident. We're going to be powering our controller box with that. We have an RJ45. This is, what is this, a cat? This is, doesn't say which cat it is on it, does it? So this is Cat 6A. There we go. No, it's so much. You see all that writing on there? You had to kind of keep turning it and turning it to find it. And this, of course, is a fully shielded cable also. You can see the metal on there, which indicates full shielding. So I like that the way they're using shielded cable everywhere that they possibly can. EMI is a real thing when it comes to adding all these electric motors to our systems, on top of maybe having a direct drive motor also at the same time. So yeah, always want to see what you can do in the manufacturing process to mitigate those issues that may come up from that. We get a bag of hardware. Even though this is made in the USA, these are M8 bolts here, and they're flatheads because we'll be going into some holes that are drilled into the mounting brackets that are countersunk. We get some feet, and I'm thinking these were probably replacement feet, these little buttons that you peel off and stick on the bottom, because all of these feet over here already have them on them. So it's probably, if one comes off, you have another one replaced with. Kind of nice. We get 4 of these. These are very thick. Let's see how thick they are. These are 12 millimeter thick plate, aluminum plates for our mounting. And we have some, as you can see here, we have some countersunk holes here. This is where we will attach to the actuators themselves. And then once their actuators attached, then we'll be mounting this part to the rig itself. So the actuator will be sitting on this side with the screws going in that way. But we'll see that once we get there. So we get 4 of those, and it has kind of a neat aluminum finish to it. It doesn't have a, see that finish? It's almost like it's got fibery streaks through it. Different than most of that stuff that I get here. Either it's really shiny or it's anodized or something like this. But this is all pretty much going to be raw stuff. Whatever. This might be an anodization on it, though, I'm thinking, because of the way the pattern is on it. See that? I don't know how that's going to show up in the camera. But yeah, there's this pattern all the way around it. Kind of a marbled look to it. And of course, last but certainly not least, we have the actuators themselves. And these are a 2-inch travel. And we're going to talk more about the actuators in detail when we get to the closer look at the actuators themselves. I just want to show you what we get here. It has this cool cooling fin on it. It's almost like little needles or pins or something. See how it looks? We've got a little port over here for USB. The foot moves 2 ways. It moves obviously for off angle when the cockpit is doing rolls and pitches and things like that, but it also will move. You can see how it can shift around inside of there too. So it can move very freely. So it will never bind up, I imagine. And there's the feet I was talking about before in that package. So that's what we get. It was very well packaged. I like the way that they present this kit already. And yeah, I'm sure we'll be able to see more detail as we go along through the review. And what we'll do next is get to a segment where I'm just going to talk about the actuators themselves, because there's some information I want to give you on those. So let's take a closer look at this DK2 actuator. We can talk about the weight. It's almost 10 pounds for a 2-inch actuator. Pretty hefty in hand, and that's about 2.5 kilos. No, 4.5 kilos, I believe. So yeah, very stout piece when you're holding it in hand. I think this piston in here definitely contributes a lot to that. The housing is a 1-piece billet aluminum block when it starts its life, and then they mill this out. All of the CNC machining is done in-house at their own factory, which gives them the best quality control probably get, I would imagine. Just nicely done. This is a tumbled finish, which gives it that marbled look to it as far as the colors, but it's very, very smooth. It almost feels like just polished, like somebody just polished it out. And that's the advantage of doing tumbling. It leaves that peened look, if you will, on the, or a textured look to it almost, even though you can't feel anything. And of course we have the logo right there with the DK actuator. The foot is also the same deal, aluminum. And this is what I would call a captive, non-captive foot. Non-captive because it can move around inside of the foot itself that would normally be not possible with a captive. You just have this motion here where we can go left, right, tilt, so that when the rig tilts, this will tilt also. But yeah, it also slides around inside of it. First time I've seen something like that. So it kind of covers both bases for non-captive and captive. We have some black pieces on the bottom here, little rubber bits. Just going to keep it from sliding around. It seems to work pretty well on my rubber mat, but we'll see once we get it over there on the concrete. What else can we talk about here? The piston inside. Let's go ahead and take this guy because I've already pulled this one out. This is a 50 millimeter piece right here. And there is a square piece to it. You can see that where they've milled this out to be square. And that's for the channel you see in there, the anti-twist element of this particular actuator. And this bolt here, I imagine that's what this bolt is for. So it rides down inside of that channel, keeps things from twisting around on us. That these tend to want to do because of the ball screw and the motor turning the ball screw. It wants the torque forces want to make this piston turn. And you notice down inside of there, there is a piece, and this is a Teflon piece there on the flat, and also this corrugated stuff you see around the edges here is also a Teflon. So there's no grease on this. You can grab it and there's just no oil. And I'll show you a closer look at that, how that works. They sent me a couple of pieces so I can show you this. Here's the Teflon sleeve. And it's supposed to have thousands and thousands of hours of durability on it. I'm sure it does. And this is the, again, machined in-house steel piston, 50 millimeters. Feels very hefty in hand. A lot of the weight from this comes from this. And of course, this just sits in here like this and goes back and forth. I'm curious to see what kind of noise, if any, or sound it makes. I can hear something here, but we'll have to wait until we have it running to see how it really sounds. If I squeeze this as hard as I can, it has no trouble moving in between that. Very slick stuff, no doubt. And this piece is what we saw internal sitting on the flat. And they say they actually print these out, but it's very slick feel to it. So of course, obviously, it's going to be riding against the walls of the actuator housing when we're using it too. And speaking of which, this is the actuator housing. You can see it is the same thing here. Obviously, has not been tumbled. And this is a scrap piece they sent me. It came out of the mill, but didn't meet their quality control standards. So into the scrap heap it went. Very well done. Look, you see the machining on here, and that's why they sent it, so I could show you guys this. Of course, this is where the motor fits on the top flange. Our ball screw would be mounted down in there somewhere. And on the other side, this is where, of course, this stuff goes. This little plastic sheath. And it goes into one of these holes. I guess it would go in this hole, because the other hole's for the, let's see if I can get this to go. There we go. So you can see it sitting in the hole there. And this other piece will come in, and this would be bolted into the holes here. You can see them down in there, in the hole. So this would fit in there like this. And there you have it. Pretty simple, huh? Simple is good. Of course, I don't have the ball screw. They tell me it's a 5/8 inch, which should be plenty for a 2-inch travel actuator, I would imagine. See if I can get this back out now. There we go. So yeah, I like that they sent me these pieces so I could show you guys the internal workings of what's happening as far as the housing and the piston riding inside of that. So yeah, let me go ahead and push this back down. What else can we talk about? The speed is, and that's directly related to the motor, so we can talk about the motor. The speed is 8.4 inches per second. That comes out about 213 millimeters per second. So plenty of speed for a 2-inch actuator, I would say. And again, 50 millimeters on the piston itself. So I think we covered just about everything we could on the housing, or rather the housing part of the actuator. This is really the actuator. This is just the motor. So the motor, that is a clear path motor. And they're known for the way they construct their motors to mitigate EMI. I was doing some research on them. It has a USB port on it, and that's for programming the parameters for the drive controller in here, servo drive. So that's right, they got the servo drive integrated into the electronics package here, along with the encoder and stuff like that. And we would go in that USB in a computer and program whatever parameters we needed as far as using this actuator. Just like you would do on a regular servo drive, but you'd use their manual buttons on the outside. They usually have a little LED screen that shows you the parameters you're changing and that kind of thing. Very nice that they've done that. I like a compact unit like this. It's going to be more of a plug and play type of solution, because we're just going to take cables, plug them in here, plug them into the controller box, and we're pretty much done. And of course, there are the plugs that we're going to be plugging into. So yeah, all integrated in there. I'm not going to pull this apart because there's really just not much going to be able to see here. It's just going to be a servo drive. As far as the circuit board, it's going to be a circuit board, not much to see. But I do like these cooling poles that they put on here instead of fins, something different. And again, the circuitry in here, they talk about it on their site at Technique. Let me show you the model number on this. Didn't show you that yet. Technique makes these. You go to their site and look up this model number and stuff, you can find all the information about it. They're big on mitigating EMI in their circuitry. They use current in their DC circuitry. I'm not sure exactly what the differences are, to be quite honest, but anyway, it helps mitigate the EMI according to them. And of course, we do have shielded cables, if you saw the closer look, all these shielded cables should help out in that manner. Let's see, it's Molex connectors. What else can we talk about in the motor? I think that's about it. 2,500 RPM. But again, you can go to look up ClearPath or Technique, and you can actually get the specs on this and see what it does. I think it's 4.4 Newton meters as far as peak torque on this. So the numbers look good, but then again, numbers can look good, but how does it perform? That's the end of the day. That's what really matters, and we're going to find that out, obviously. So not much else to talk about here on the actuator. What we'll do is, just get on to the next segment. So now we'll do a look inside segment on this DK controller box. I've already taken the screws out. I'm going to go ahead and lift this up. I have to be careful because there is a unit attached to the top also. I've already unplugged a couple things in here to try to make this easier. There we go. Pull straight up. And there we go. And you can see we have a power supply in here. Let's go flip it around straight maybe so you can read it better. And this is also a Technic unit. It's an IPC5. They call this an Amazon IPC5. All right, and it's got some plugs that go to it here and up here. And you'd see those when you took it off. Oh, and it's got the same kind of heat sink that the motors do. Check that out. It's got the poles instead of fins. It's got their logo in there. Very neat. Set that aside. And a very clean enclosure here. Look at all this room in here. We could put some more components in here. You could do like maybe a 7 actuator system for 6 DOF in the future. Of course, this is our mains, our fused mains here. Very nice shielded unit. See the metal shielding on it. We have the controller over here. Of course, you can see that's our data port, the RJ45. And that's their controller board. Get you a close look at that. Looks like we got a little SIM card hanging in here. USB port. That's not USB. Down underneath there is. I'll show you the other side in a minute. But yeah, that's what the board looks like. And this is the power distribution board coming off the power supply. This plug comes off the power supply. And this is another one that comes from the power supply. So this is how we get the power to our power ports on the top there. And of course, underneath will be the data distribution. And all this is circuit board, so there's no wires in here. Very neat looking. Let me flip this around so you guys can see the back part there. Very neat in there. Very professional. Geez, look at all the room. I don't think you're going to have any cooling problems in here. Although we are going to have the power supply sitting in here where that's why these vents are here. And that's why we have this 2.5-inch fan to blow right on the vents. Or actually on the power supply, which is going to go through the vents after it goes through the power supply. Yeah, very, very clean and neatly done here. Not much you guys, but yeah, there's not much drama going on here, is there? Not much else to show you. So yeah. Very clean. I like what I see here. Very professional. And I also like to point out when I see it, they've coated the inside of their enclosures just as well as they coated them on the outside. Again, usually that's a mark of a company that has quality control and quality in general in mind when they're making their products. Right. So that's the look inside. Now we're going to attach the mounting brackets to our actuator body. And if you saw the closer look, you've already seen these. A little over 12 millimeter thick aluminum. They have 4 tightly spaced holes here, and these are what we're going to use to go into the body itself. You can see they are countersunk. We'll be using flathead M8 bolts. And on the other side, we also have some countersunk holes and countersunk slots. Now the slots give you a range of 45 millimeters to 35 millimeters as far as channel centers. I already measured that out. So it does give you some wiggle room in here, or about 1 inch to 1.75 inches, I think it was. So you can use other profiles with the same bracket. I like the way they did this. A lot of manufacturers would just do a dedicated 40 series bracket for this, but some manufacturers don't, which is good because then you can use it on something else if you need to. Pretty simple what we're going to be doing here. The actuator housing has its pattern already drilled and tapped for M8 bolts, and we'll just be sitting this on top of this piece like this, and they provide us with the bolts and hardware we're going to need. These are the M8 flathead bolts, and they are a 5 millimeter hex wrench size. that's what we'll be using to put these in. And you get a bag of them. You get a bag for mounting to the actuator, and there should be enough in here for mounting to your chassis too, or your cockpit. And they also give you these spring ball T-nuts, 40 series. Very nice that they actually gave you the mounting hardware for the actuators. You usually don't see that. I mean, you might see it for the bracket itself, but yeah, not for the actual profile. All right, so pretty simple here. We're just going to line these holes up, look straight down, get them started, and then we're just going to twist them down with our M5 wrench here. These are going in really easy too, by the way, which is a good indication of quality control here. I don't feel like I have to pull my tap out and chase the threads like I do on some holes that are drilled and tapped in some hardware pieces that I get. Yeah, this is going in pretty well. And I'm going to use another wrench to tighten these down. Now, these are going to be blind bolts. What I mean by that is we're not going to have any access to them after the actuator is mounted, obviously, because it's going to be sitting flat up against the profile. And then we're going to have these bolts going into the profile itself. So this is where you want to make sure that you get these things tightened down to your final tightened torque, wherever you feel that should be. And you don't want to have this thing coming loose on you. That's the whole point. And I don't think it will if I get a good tighten on this. And of course, I'm using the regular kind of wrench to get some torque on it. That feels pretty good there. I'm confident that'll work. So there we have it. Again, very easy to do, and we have to do all 4 of them. And then once that's done, we'll go over and attach them to our profiles. We're going to be attaching this to a 40 by 160 40 series profile. So we'll get to that next. I wanted to take a closer look at how this foot is working on this actuator. If you saw a closer look, you know that this is kind of a captive, non-captive setup. It looks like a captive one, and it has the ball that moves around like in a captive type of foot. Then we have this, though, which is like a non-captive movement. So it moves within the foot. So we kind of have a foot within the foot, or this is just an encasement. We're going to find out. Now, if you remember, on the bottom here, they had these rubber buttons, if you will, self-adhesive units that they were using for the foot as far as grip goes. And I had to take those off to get to these screws here. And speaking of which, we now have a new piece that's going on here, like this. So that's going to cover more area. Much better solution, I think, than having those rubber buttons on there, even though I have some extra that I was going to put back on here when I was going to do this anyway. Now we have something a little better. This is about, I think it's almost 4 mil thick, about 3.5 or so. So a nice thick piece of kind of a sticky rubber. Not really sticky, but just feels like it's going to grab good on like a wood floor or concrete floor. And it's a 3M adhesive on the back. Very good stuff, I think. 3M usually is. So we'll see how that pans out once we get it put back on. Now, these screws here are thread locked, as you might imagine. So I had to heat them up to get them off. But I had to heat up the foot anyway to get those rubber pieces off the way I like to take things off. So I'm going to take these off. Now, I've already taken these loose because they did have thread lock on them. And while it was hot, when I was heating them up, I had to get them off, obviously, to get that out. And now we're just going to go ahead and take them out. And I'll start with, I'm just going to rotate it as I do this. And these are M5 flathead. And there's a 3mm wrench size on them. Of course, this is so they can fit down in that countersunk hole. Go ahead and take this one off. And there's the cover. Again, this has the same tumble finish on it, as you know. And it even has the tumble finish on the inside. How about that? Now, what you're seeing here is what looks to me to be some kind of a dry Teflon or graphite. And this dry lubrication is keeping, along with the theme of what they're doing here with the sleeve they're using here, this Teflon impregnated sleeve that they're using for the piston to go in and out on. So that's what you're seeing here sitting on this. And you can see some of the wear marks from where it's been moving around. Now, what sits on top of that is this piece here. And this is a very slick piece too, even though it still has that lube on it, that dry lube. And you can see it has a conical shape to it so that it fits on the foot in here. Of course, it'll slide around on our plate like this. And then here's the foot itself. And it has a concave shape to it, of course, so it can fit inside of there. And you can see the lube on that too. To get these on and off, I have this piece here. Obviously, they put some kind of a rod in there and allows them to twist or screw the foot in and out of the piston for maintenance and assembly. So there it is. That's all there is to it. Pretty simple. And I think it's going to be pretty effective. Of course, I won't know for sure until we get this thing bolted on along with the other actuators and we're running it on the chassis and just see how that movement works. Again, with this kind of a captive, non-captive setup. First time I've seen something like this. So yeah, I thought it was worthwhile to go in and take a look inside and at the same time update you guys with the new rubber feet that we're going to be using. So I have the actuators staged and we're ready to attach them to our GT Omega Prime cockpit. Now I did a review on this cockpit just recently, so I thought it'd be a good candidate to use these actuators on. Plus, it's about exactly the same as far as dimensions go as a P1X. And you can see the actuators stand on their own, which is kind of cool. The front is sitting on a jack. It's the official SRG jack. I have it underneath here, the P1X pedal tray, and this is the only pedal tray I know of so far that I would do that to. Because it's such a heavy-duty unit that, yes, you can actually lift it up with a jack with the pedals installed. Don't have the wheelbase installed, but do have the pedals installed. Now, over here on this side, I have the other actuators staged. So now, all we got to do is get down here and install the actuator. The GT Omega Prime cockpit, their profiles look very much like the normal 40 series that I get around here and I've gotten from SimLab and some other companies, but the channels are deeper. They use a different kind of T-nut that has a leaf spring piece of metal spot weld to the side so that it will stand it up in this deeper channel. These nice spring ball units that you get with your DK2, which are better T-nuts in my opinion anyway, than those leaf spring jobs because they hang up in the channels, they don't slide as well. Anyway, they're too shallow. So I'm going to have to slide this in. No big deal. I probably would have done it this way anyway if I was installing them. So that's what I'm going to do now. I'm just going to go ahead and pick up the actuator, look straight down on it, and feed these in. Now the T-nuts, I'm going to start them in with the shorter side where the bolt is actually in it, so that the long side of the T-nut where the spring ball is pointing inwards. And I'm going to do the same thing over here, so I don't have to see the T-nut sticking out the edge when I have it in the channel. Just an aesthetics kind of thing, but yeah, it's just one of those things I always do. So I'm going to go ahead without further ado here, get these to hang down so they're out where they need to be. Small side first. Same one down here, and there it goes. Pretty simple as you can see. Now on these, the long side's going first. So go ahead and get that one lined up. Split this one around here. And there we go. Could be easier, right? All right, so now I have this back here. There is a weight consideration here when you're setting these things up. I want to have as much as possible anyway, 50% on each end of these actuators where they're sitting on the chassis. Can't do anything about the width because it is what it is, but as far as the length goes, I'm going to try to get that weight. Now I do have some problems with some brackets here that are holding the upright, but that's with just about any cockpit that has this type of wheel deck on it. So that's going to limit me in this area of where I can mount. But I think if I take this actuator and put it all the way back up against front here, I'm going to have a pretty good weight distribution. And you can find that out by jacking this up, putting a weight or a scale underneath each actuator, take the reading, go to each four if you got the time and you want to do this. And then you can see where it's going to be heavy. And of course I got to put my wheelbase on here, the steering wheel, and any other peripherals I'm going to put on here to find that out before you do that. And that's what I'm going to do once I get everything mounted up and get that all sorted so I get as close as I can. Remember, most of the weight's going to be here with my body, 155 pounds sitting right here. The rest of it's the pedal tray, the pedals, and the wheelbase. So when we come back, I'll have them all connected properly or mounted properly, and we'll see how that looks. So I have everything solidly mounted now. The actuators went on very well. You know, I really like these brackets. They're very thick, as you saw in the closer look in the mounting segment. Really, the whole thing is a commercial quality build as far as I can tell. It's very heavy duty everywhere as far as everything, the way it bolted up. Yeah, there's no fear at all of any flexing or anything going on with this actuator housing and this bracket mounted the way I have it here. I did end up getting this one on the front. You can see where it's bumped up against the bracket here. That's as far as I can go without moving the wheel base upright bracket itself if I needed to. I think this is going to be pretty good for the balance though, and I typically run them this way. We'll go ahead on the other side, see how those came out. And I do have some, starting to mount my peripherals, I'm mounting a DD1 Fanatec wheelbase. I've got a handbrake over here I'm testing. Same thing over here, and I did measure, so they're spaced exactly the same on the rears on both sides. We'll go over here to the front. You can see I did the same thing on the front here. I butted it up against the wheel upright bracket. Everything's securely fastened. Feels very solid again. I sit in it and nothing moves, so that's always a big plus. So the next phase is getting all our cables attached to our controller box. I have the cables connected now to the actuators, and you can see they're running down the sides here. We've got a blinking green light up there, which means the system's ready for action. And over here on this back one, I'll show you that also. I'm using these clips that you can put in the channels on 40 series profiles or other series profiles, depending on the clip size. And you can use zip ties to secure your cables. I use these a lot because they're very convenient. We have a couple more in the front here, and they are just before the pedal tray. Well, you can see them, but they're hanging there. And then I have one underneath the pedal tray on the left side, and one on the profile here on the right side down here. And there's the one that's sitting up there underneath our pedal tray. Nice cable management system there. Not the best cable management right now, but of course, under testing, that's what we get. Now you can see, obviously, we have the lights on our controller box. And I'm going to show you a little sequence here that goes through a boot up routine where it's a self-calibration, and I just turn the switch on. You can see the lights come on the controller boards on top of the actuators. The actuators are moving, and yeah, it's just going through its sequence there. And it'll go through some, I think it flashes the yellow light once, but what we really want is that steady green flash, that rapid flash movement, and that means everything's good to go after it does its self-calibration. Now I'm using the RJ45 hookup here. There is a USB dongle available. If you need that, they will give it to you. And they're working on a standalone USB solution right now. But right now I'm going from the RJ45, and we'll talk about that once I get to the software. And it's coming over here to my back of my PC where I have two Ethernet cable connections. The blue one is my network, and the one underneath is going to the control box. And it works like a champ, really. There's no problem getting it running as long as you have an extra RJ45 port. If you don't, then yeah, you have to do the USB dongle. And we'll talk about, again, how this is set up once we get to the software part. So everything's up and running, and yeah, so we're ready to get into the cockpit and take a look at the software before we actually do some running. Now let's take a look at the application we're going to be using to tune our motion system. I have it open here, and the first thing you'll want to do is go over to this icon on the upper left corner and put in some measurements. You can see that has a representation of your cockpit, and we have our actuators going around it. And what they want is the centers between the front left and front right, and they're going to want to have the length between the front and the rear actuators, which should be the same for your both sides if you've set this up properly. That's what you need to do. Make sure the front, the rear lengths on both sides are exactly the same. For width, I came up with 26¼ inches. For length, I came up with 38½. So once you put those in, you're good to go. Then you can power your system on and start using the tuning. And when you power your system on, I'm going to move this over so we can put a little inset on. This will go to its halfway position. Remember, we have 2 inches of travel, so it'll go up 3/4 inch. So we'll go ahead and power it on, and you can see it go up. There it goes. It'll go up to the halfway position, and then we're ready to do whatever we want to. So now we'll go over and look at what's going on as far as our tuning options. And you can see there's not very many. There's only 5 currently. We have heave, environment, gas brake pitch, turning roll, road vibrations, and then we have a couple here that are coming soon, engine vibrations and smoothing. Now, I was able to get a pretty good experience out of this with just these 5 sliders. But of course, everybody's a little different how they feel things. Now, heave. What does heave do? Well, pretty much what you think it does. It's the up and down motion that we get on a system that has 4 actuators attached like this. So yeah, pretty much that's what it does, heave, and the intensity. And by the way, the intensity gets more as we move it to the right, and that turns it into a 5. And these numbers will change as you move these. I'm going to move this one over here, so 4. I can go back to 3, 2, or you can just turn it off if you want. Out of the box, they're all at 4, by the way, you'll notice. And that's pretty intense. I definitely changed that for my running on regular tarmac, like a circuit car, right, for circuit racing. And also changed it when I was doing the Lucas Oil trucks and stuff. All right, so the next slider is what they call environment. And their description of that is it captures the essence of the track environment, pitch and roll. So if we have rapid elevation changes, or we're hitting curbs, bumps, and dips, and the road texture, this is what they're calling their true pitch and roll of the car chassis, based on the telemetry feed they're getting. Right. So what is, if that's pitch and roll up here, what is gas brake pitch and turning roll? Well, these 2 sliders are like a boost or fine tuning of the environment, whatever's going on in there. So if I have too much of a pitch, then I can come in here and take the slider and either turn it down, or if I want more pitch, I can go up to 5. I had mine down a bit, I believe. So we're able to tune the roll the same way. We can grab that slider and tune that up or down as far as the intensity goes to make it a little bit more selection, more choice, or a fine tuning, if you will, of what's going on with the pitch and the roll in the environment slider. So this is like the big guy that changes everything at once, and then we can come in and fine tune with this. Road vibrations. These are the high frequency vibrations in the suspension displacement physics. So basically, obviously, what this does is when hitting rumble strips and things like that, we're going to feel the texture of those rumble strips. This layer is independent per motor, and it gives that 3D spatial sense of where the vibrations are going to be. So each one of our actuators up here are going to get a different signal based on telemetry the road vibrations algorithm is getting. And then, of course, we have the other 2 that are not active. So that's it. That's all you have to do as far as tuning it in. As I said before, they're going to be coming soon with these other ones. Right now, as the taping of this video, I believe this is the 3rd iteration of the software that I'm on now, which obviously is an update for the firmware too and how everything operates all in one package here. So right now, I've got the latest one as of this testing. And if you look down here, it says software, I don't know if you can read this or not, 1.1.58. Firmware is 36, and the hardware is DK2. So that's it. How simple can you get, right? So what we're going to do next, now that we know what we're going to be using as far as tuning. Oh, one more thing I want to go over. This web engine they have, a web UI engine. So you can actually download, well, actually have this on a browser if you want. I'm going to open up the web UI and see what happens. I'm not going to worry about the settings here. So I'm going to open that up, and you see I have this little thing pop up. It's called the web UI modal. And we can open up in a browser that's on this computer, or you can scan this QR code with your mobile device, like your phone, and if it's on the same network that this is on, you should be able to connect to the app. So I'm going to do it in my browser. I tried it on the phone, it didn't connect. I think my firewall was blocking it on this port number down here, 5077, and I just didn't have time to mess with it there, but it shows you what it does here in my regular browser. I'll click on that. Brings up some Chrome here, and there it is. And if you look, it is, well, it's hard to look because now it's covered up, but everything is the same down here. The software, it's the exact same what we have on the other application function. We see in the background there, the gray here, but now it's on our Chrome. So we can power off, we can power on. I hit the power off, see if it works. Yeah, we're going down. And we can go in and change our variables if we want sliders just like we could before. Let's see, I moved it to 3. There it goes, 3, 4, 5. All right, so a nice feature, I think. We'll go ahead and close this and see what happens. And we'll close this. So if you have your phone, you don't have a 4th monitor, you have a phone, then you should be able to, with the right firewall settings, connect to this app if you're on the same wireless network that your computer is on, or the same network that your computer is on. Shouldn't be a problem. So there you go. And this is, again, early days for this application. And they're going to be making some changes, obviously, as this evolves and they get more of a fine-tuning options, or not options, but fine-tune what they want their algorithms to do with the telemetry that's streaming in. And they are currently working on that all the time, they tell me. So yeah, I expect to, probably before this review is over, I might even get another one that has some different stuff in it, or a different way that they want things to work. But I found that I could tune it pretty good in here to get what I wanted. That's what we'll do next. We'll just get into a live tuning session and see how these sliders actually affect the motion itself. All right, so now we're in iRacing and we're at Sebring in the Ferrari 488 GT3. As usual, the baseline testing that I use. We're going to start out with this thing at all fours, and that's how it came out of the box default. And I'm going to go ahead and start driving, and we'll try to describe to you what I'm feeling here. I got the motor sounds turned down a bit so it won't interfere with me talking to you. I tell you, it's like I said before, if you watch the application overview when I was going through it, yeah, right out of the box, this thing is active. It's got a lot of pitch in it. It's got a lot of roll. You can see as I'm rolling here. And if I hit the brakes, look at a lot of pitch in there, which was way more than I thought I needed. Now, as far as the heave, I'm not sure yet. We're just going to have to take care of my pitch and my roll first. So what I'm going to do first is go in here. Yeah, this thing is pretty crazy. If you go off the track, let's go off the side here. Yeah, you can hear the, I hope you can see that in the video I'm giving you a shot at while I'm driving this thing. But yeah, this is a little bit, actually a lot more than what I would need for the car to feel right to me. I'll tell you what they do have though, when you hit these rumble strips, they're very good at it. They've got that nailed. All right, so what I'm going to do is, first thing, I'm going to get rid of some of that roll. And remember, environment is everything together. The roll, the pitch, some of the heave, and we can fine tune with heave, pitch, and roll down here, the gas brake pitch and turning roll, what we want. And of course, road vibrations. If I want more a rumble strip effect, that kind of thing, bumps when I go up on the curbs, then I can increase that. Well, it's pretty high already. What I'm going to do first is get rid of that, the turning roll. And I'm going to take that down to 2. If I remember right, I think that's where I ended up with it. So now let's go ahead and start going, and then we'll see how much roll we reduced by going down to 2. Still got a lot of pitch. And it's still got some roll in it. You can see that. Okay, what I'm going to do now is, because I think the environment, everything's just a little bit too much, I'm going to go ahead and go back up into environment and put that on 3. See how that did. Now, you don't have to save it. It immediately takes effect real time when we're doing this. All right, so now we've turned the environment down a little bit. So that should have, yeah, I think I took some more of the roll out. It depends on what kind of car I'm in, as far as what I think it should feel like. I'll go up on this bump here. Yeah. And it's got some good vibrations in the textures when you're rolling over stuff. All right, so I'm going to let the roll stay there. Pitch is still a bit much. I'm going to take that down. I'm going to go to 3. See how I like that. Okay. And the shift is pretty heavy too on this. That wasn't too bad on the pitch. It's a rumble strip. I love that rumble strip. All right, so I'm going to go ahead and get on the brakes here in a second. Yeah, that's better, I think. Got plenty of speed here on these actuators too, because I can feel the speed of this. How, I don't know if it shows or how well it conveys on the video, but it's got some speed to it. Slider here. Man, these rumble strips. Pretty intense. All right, so I'm on 3 on pitch now. That's still a little bit too much. I think I'm going to take it down to 2. Let's see what happens then. Again, totally subjective, so just because I like it, let's see if I can get this thing going with the clutch here. doesn't mean that somebody else is going to like what I like. Of course, I always say that in my videos because we're all different. I'm going to go ahead and go through the turn here and see how much pitch I get on this heavy braking zone before we get into turn 17 here. Yeah, that seems a little bit more realistic to me for what you would be feeling. I think the road, I'm going to turn the heave down too. It's still at 4. Yeah, let's get some heave off of there. Like I said, I don't know how well this is conveying. I'm going to go ahead and get my road vibrations to 3 too. See how that goes. It's all a little bit too intense to me as far as what I'm feeling right now. Here we go. So I should feel all the bumps going down the straight here, the home straight, finish line. Yeah, that feels a little better now already, I can tell. Let's see, it goes pretty bumpy around this turn 1 here. Yeah, it feels a little better, I think. As we spin around. All right, here we go. Back on the road. And you can hear the actuators moving. It's still a little bit more roll than I think should be in there. I'm going to turn the roll down to 1. See what that does. Well, I'm going to turn it off too if it doesn't do it enough, and see what happens when I turn the turning roll completely off. It may not need to do that though. Yeah, this is better. I don't know if you can tell if it's better, but yeah, I can live with that. But I'm all the way down to 1. And environment is at 3, where heave is 3. So let's go ahead and run at speed and see what we can feel here. Trying to get the car to feel like with any motion system, what you might think it should feel like, but also very important is feeling what the car is doing so you control the car. If you can control the car based on the motion sensations you're getting and feel like you're controlling the car, you're going to put better consistent lap times in, no doubt. And that's what this really is all about, trying to get it tuned that way. Right now it's feeling pretty good. I think this is probably where I had it, or very close, before when I was doing all this testing. I've been putting a lot of hours on this system. And yeah, it's still got great rumble strips. Road vibrations are still at 3. So when I'm going over any of the curbings or the rumble strips, it feels good. It doesn't feel too harsh. Go over this here. Yeah, that felt pretty good. Now, because these sliders only go from 0 to 5, obviously, some good rumbles. Obviously, that's not gonna give us a lot of fine tuning, I guess what I'm trying to say, where some other motion systems in the software control it give you a little bit more leeway with how you can fine tune it. But this is what we have for now, and it's working. I can definitely feel what the car is doing now. At least I feel like I can feel like the car is doing. I'm getting enough bumps coming across turn 17, going down the straight here. And Sebring is a very, very bumpy track. Just ask anyone who's actually driven it. And yeah, that's what you want this to convey to the driver. And feel the weight transfer when I'm coming through that turn with just enough roll to do that. Yeah, this is feeling much better. If I can keep it on the track. Okay, well, I didn't hit the tires, so that's always a plus. I'll take it. Not easy to talk and drive at speed at the same time. There we go. All right. Let's see how it feels when I get into the end of this long straight, into the heavy braking zone for the hairpin up here. See how that feels. Here we go. Yeah, that felt pretty good to me. I don't know how that looked on the video, but it felt like I had just enough pitch in braking to where you would think it would be. Also, going across those concrete patches feels very good. You can feel that transition. I could feel the transition from there. You can feel it coming off of that concrete here onto this asphalt. And that's another thing that you want in a motion system is sensitivity. And not only that sensitivity, but the speed to deliver it. You can feel when you're transitioning definitely from the concrete to the asphalt. They've got that nailed down pretty good here too. I would like to see that smoothing in, because I almost feel like I want a little bit more intensity, but not quite as much if I bump it all the way up to from like 2 to 3 or 3 to 4 or something like that. But these rumble strips are just awesome. I mean, you can feel the whole chassis. It's actually more on the left-hand side on that rumble strip than it is over here, but you can feel the whole chassis absorbing those rumble strips on each one of those edges as your tire rolls across it. Yeah, here we go. Yeah, being able to push it through that turn, you saw I had to do a couple of corrections, is very important. You're always on a fine edge there because you're turning. You got all that weight transferred, pushing you out to the outside of that turn, and you're skipping across at the same time. So yeah, it's not easy to judge that. Or this section here, that's a hard turn too, or turn 1. I think I like what I have here now. Okay. Yeah. The pitch is not too bad when I'm hitting the brakes. It almost feels like you would expect a tightly sprung GT car to feel like when you're pushing hard in it. Because if you watch those in racing, they don't pitch a lot when they get into the heavy braking zones because they just don't have the travel to do that. But you can use pitch, and a lot of people do, to simulate. Let me see this transfer across this concrete patch. Yeah, you could see this just the second that I hit that concrete patch. I could feel it in the suspension, and hopefully you could see it move in the video when I went across that patch. So everything, there is no latency here. Everything happens right as it happens as I rolled up on that curb there. So yeah, you can't complain about that. There's just no latency here. These things are very fast. And again, we're only moving 2 inches though. So yeah, there's plenty of speed for 2 inches, no doubt. But, yeah. This is a fun system. Again, I like to see some smoothing because I feel like I want to go just a bit more. Maybe heave will do it. Let me try road vibrations. I'm going to turn road vibrations back up to 4. It feels like I'm just missing just a little bit of intensity that I prefer. And of course, somebody else sitting in here might not prefer that. They might get in this thing and go, what are you talking about? Yeah, that definitely turned it up a bit. But if we had that smoothing slider, I think that we could do a little fine tuning with that. But I can live with this. I'd rather have it a little bit more intense than I ideally want it to be than to not be able to get it to be that intense and be softer, if you know what I mean. And I can feel every bump coming down that straight. And we're going to get some jolts coming through here, I'm sure. Yeah. Just by turning the road vibrations up, we got that. Coming down the straight. Wow. All right, so coming through, this is a tough turn, so you can see all the bumps on this track. But yeah, I can't wait till they get the smoothing slider in. I think that's going to help get a little bit more fine tuning that I think needs to be in the system for me anyway. But yeah, I just want to give you guys a general idea of what you can turn, or rather tune, when you're sitting in here and using this DK2 system. And I think they've done a very good job. The rumble strips are just nailed. And any of the bumps, the transitions between the asphalt and the concrete, right on. There's no latency there. You feel it right away, and it feels like you're transitioning from a different surface to another surface, which is very important because that also tells you, when you're transitioning from one surface to another, it can get or more slick or less slick depending on what transfer you're doing there. So that's something you want to feel so you know what inputs you need to do to control the car and keep it getting out of control, obviously, and going off like I did a couple of times there. So I'm pretty happy with what they have here, and I'm really looking forward to, as they keep evolving with this application. I think it's very good right now, but it's going to be really good once they're finished with it and they get a couple of other things sorted out here with the engine vibration and smoothing. And of course, we want to be able to save our configs. If I was going to save this config right now, I would do a screen capture of my setup, and then I would save the file with the name of like Ferrari 488 GT3 at Sebring. And yeah, I would just leave it at that. And then I could load it once I got back in. I could actually load that picture up and I could set the sliders. But obviously we want something a lot more convenient than that. And they are coming with it. But yeah, they're working on the motion part first to get that sorted as best they can before they start adding the save game stuff. So it's early days here for the DK2 and the guys at Sigma Integral. But I think they're doing a very good job, and this is going to be a very good system. It already is a good system, but it's going to be even better as they get this firmware or the software app tweaked a little bit more to where we have a little bit more options as far as tuning goes. Anyway, so that's it for our live tuning session, and we'll just get on to the next segment. We're in iRacing at Sebring in the Ferrari 488 GT3, and yeah, we're here for the bumps and the transitions and everything else that we can throw at the system. This is a great test bed to test any system and see what it can do and if it has any weaknesses. And just coming down here, this system does a good job. You can watch me hit the little bumps here on the straight, on the start line straight. And then coming around here on turn 1, there's also some pretty nasty little bumps. And you feel all of this. The system is very fast, so you can feel all of those textures coming through the chassis. I like the way they've got this tuned for that. And they told me at Sigma Integral when I was talking to them that they developed this and are continuing to develop the 2-inch system as a circuit racing system. So we're always on tarmac somewhere when we're racing with this system, and that's what they're really going for. And I kind of can feel that because there's a lot of texture going on here. Of course, right out of the box, if you saw the live tuning bit or segment that I did, then you could see there was a lot of roll and a lot of pitch. And that's trying to give you the sensation of surge and the sensation of sway. But when it comes to circuit racing in this type of car, it doesn't move that much in the suspension, maybe 2 inches. And when it rolls or the weight transfer comes from one side or the other, or when you're in heavy braking like right there, I try to replicate what I think the motion or the movement should be. I'm not trying to add things like sway. I just want to feel what the car's doing, or when I'm on the brakes hard, and be able to repeat that feeling so I can better negotiate the braking zones. And as everybody knows, you can gain a lot of time and do a lot of passing if you're good in the brake zones. So I think this system gives you the information you need to perform that. The rumble strips, these are a treat. I remember the first time I got in this and I went over some rumble strips here at Sebring, and they were just awesome. This big fat one coming over here, you can just feel every little edge of that on your tire as you're rolling over it, and you feel it biased over to the left side. So they've done a good job with how they're doing this. They actually have the road sensations so that each individual actuator is actuating by itself when it comes to the vibration stuff. So again, I think the system, because it's so fast and it's 2 inches of travel or 50 millimeters of travel, it's able to deliver the goods when it comes to the circuit racing. I was able to get this thing dialed in where I was doing consistent laps within a few tenths every time if I didn't make any mistakes, which I still do. As many laps as I put around Sebring, and I still make mistakes because I'm always kind of pushing it when I'm just concentrating and driving, because that's just, I guess we all do that when we get in and we're driving around the race courses in one of these simulator games. But yeah, overall, I think they've done a good job here with the circuit racing piece. It's going to get better as they come out with more of the tuning selections that we can use, like the smoothing and the engine vibration. And yeah, I'm anxious to see how quickly they develop this system into what I know it could be, or can be rather. And it's really good now, but I think they're going to be able to tweak this so it's going to give you that little bit of finesse adjustability that you need to get the feeling that you're going to want, and give you a broad range of that, because again, we all kind of want different things, it seems. Okay, so we're over jumping around here in the rallycross track, and this is Sonoma. We're in the Fiesta, and yeah, I also wanted to get in the dirt and slide it around, see how it handled the yaw in the rear. Obviously we don't have any yaw, but how it simulated that. And really just gives you kind of a bumping sensation when you go one way or the other, but this is kind of a bumpy track anyway. The dirt's always kind of bumpy and slick. But yeah, it's not going to give you much in that department. Here's where you would turn roll up or pitch to try to increase that feeling. But it's a very fast system. Watch how you land on this bump. If you watch where I'm hitting, you'll see where the tires are actually coming back down, making contact with the dirt, and then the suspension compresses down on top of that. And it feels like there is no latency at all when I'm in this. I mean, it's just like exactly what I'm seeing on the screen. And to push that even further, of course, I have to go over to the Lucas oil trucks in the four-wheel drive truck here. And yeah, this is a lot of fun, but it's also the torture test, as I like to call it, for any suspension system that I'm testing, just to see how hard I can push it and see if it reacts badly and stalls or has a problem or I burn out something or break something. But yeah, this system is, like I said, these guys have been doing commercial motion systems, heavy duty stuff, big stuff for full-size cars and things for a long time. So I imagine they don't have any problem being able to handle what I'm putting on it right now. And it's reacting quite well, I think. It's fast enough. Obviously, we don't have the travel like on some of the 6-inch systems that I've tested. But yeah, it's still a lot of fun. If you ever get a chance to do this, by the way, get out there and do it. But it's also a good place to see how loud a system is. And so I'm going to shut up now and let you guys listen to how loud it is. All right, so that was a good run through the jumps there, and it gives you an idea of how the system, the noises that it makes. Now I could turn the volume on this in the video up or down to make it quieter or louder. So it's kind of relative to what you're listening to here, but I'm trying to give you an idea of the sounds it's going to make. It's not the quietest system I've ever driven, and yeah, it is what it is when it comes to that. But again, I don't ding it for that because it depends on where you're going to be running your motion system really at the end of the day. I think that's what's the most important consideration. If you have a place like I do, it's away and won't disturb people, then it really doesn't matter how loud it is, because once I turn the engine volume up and when I'm actually racing, yeah, I can't hear anything anyway but the engine vibrations. Or rather, not the engine vibrations, but the engine sounds. It's all relative really at the end of the day, but I do always take the opportunity to give you guys a chance to listen so you'll know at least what it sounds like. So yeah, I guess that's it. That's going to be the end of our driving segment. And yeah, we'll just go ahead and get to the final thoughts. Final thoughts on the DK2 motion kit from the guys at Sigma Integral. They are located in California, where they do all their own CNC work on actuator housings and other parts in this system. I would classify the DK2 system as a true turnkey unit. Remove the parts from the box, mount the actuators, plug in the cables, and you're ready to go. The actuators are built to a commercial quality level. Every part has a very stiff, solid feel to it. The actuators employ a dry lubrication solution, using Teflon impregnated plastic sleeves to handle the friction created during actuator movement. The pistons are 50 millimeters in diameter and made of steel. The total range of the actuators is 50 millimeters or 2 inches. The motors the DK uses are quite different than what I have tested to date here at the SRG. They are ClearPath units manufactured by Technic. They have integrated servo drive circuitry in the motor's encoder housing, a slick, compact solution. The controller's box interior is noticeably empty in the absence of conventional servo drives normally required for every motor in the system. Also sporting a very professional, clean-looking layout. Mounting the actuators to 40 series profiles was very easy using the 12 millimeter thick aluminum mounting plates. Once everything was cabled up, it was time to do some real testing. One thing you notice right away is the automatic balancing of the DK2 system. If you shift your weight in the seat while sitting still, you can feel the system adjust to that movement. This is the first time I've experienced something like this. The Velocity Trap tuning app is very easy to use, and I was able to find a good setup that allowed me to drive consistent lap times. Currently, the app is only supporting iRacing and Assetto Corsa racing softwares. Sigma Integral is continuously updating this control solution to bring more features. As of this testing, I was not able to use the upcoming smoothing and engine vibration features. The noise level for the system is more than some others that I have tested, but not something that caused me to give it a ding, as it really depends on where you will be running your motion system. And at my usual driving sound levels, it didn't bother me personally. Overall, I think this is a very good driving experience, and I'm quite certain it will get better as the guys at Sigma Integral evolve the software that controls the DK2. At a price of $4,900 for the kit, I think it's worth a look if you're in the market for a true turnkey motion system. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.